one of the things that I wanted to go through is I wanted to talk about the project life cycle within LF Energy. I want to talk a little bit more about LF Energy because we're talking about open source, but maybe helping to ground why we would want to do a capacity building workshop like this and training, and to really be able to elevate and get people to collaborating and working together. So I wanted to talk about project submission, and then we were going to go over the high-level architecture. We have two people here who spent a lot of the summer working on it, Benoit Jensen and Aron Stam from Alliander and RTE, and so it is really it's a great start on a high-level architecture that looks across high, medium, and low. So it's kind of going down into the energy part, as opposed to being up a little bit higher, talking about open source in general, and open source program offices in general, and strategy in general. So I'm gonna talk a little bit about LF Energy, and so at this point we have 32 members, and there's a lot of interest that's coming in, with new members coming on board, and there's been a lot of questions about, well, if we have software, how would we put it in? And it's not about convincing me about your software. One of the things that makes the Linux Foundation neutral is that the LF never is the one that decides on the software. It's the community that decides on the software. So when I think it's important to recognize that when I cast out to 2050, and I really think about how are we going to get there from here? And so the focus of LF Energy at this point really is beginning to bring software in, bring members in, create capacity internally. And that while most of the folks in the room here are really more on the power system and network operator side of the house, there also is a great crew from ELAD that's focusing on the open charging. And so we really hope that we will have an electric mobility project moving forward. There's a great amount of effort that is coming about with regards to a climate accounting project that would ensure kind of a neutral origination for what's on our grids and what's coming into countries. And then there's behind the meter, and then there's collaborations with groups like the Zigbee Alliance that are, working with Amazon, Google, and Apple on basically the interface to the energy system, which is going to be through the home. Through those voice-activated devices. Those are really going to be the user interface for your average customer to how their home and their appliances and their stuff interacts with the grid. So, there's a lot going on. I show you this, that there's a very clear process, and some of them start with special interest groups or working groups. One project that we're working on right now is the Digital Substation Project. Really started as a working group, and it came out of an end user, SIG, composed of utilities. So you have groups that start, they come up with a project proposal, and then there's incubator, growth, and impact. And you'll see when I show you the next slide, kind of shows you where to look on our GitHub site for the project proposal and submission process. We haven't updated all the language, so I have a little bit of cleanup work that needs to get done around that. But this pathway really is about each one of these stages, what happens is that, you might have a project that is, one company submits, but then it's really about how do you get it to growth. Growth is really around including that there are other maintainers, that there are others that are engaged in the development cycle, so that by the time you get to impact, you have a really big community. And so a large part of what LF Energy is about and what we spend our time working at the Technical Advisory Council is making sure that everybody has roadmaps. And with the GXF announcement today, one of the things that we asked every single one of the projects to do is to put their roadmap up, and for there to be a consistent README file at the top of all of the GitHubs of all of the projects that basically says, this is where we are, this is where we're going, this is what we're looking for, this is what our next steps are. Because what we want is to be able to drive community. And driving community is what enables adoption and then diffusion, and it enables the projects to move along in that process. Does that make sense? Okay. So that looks terrible. If you just were to Google LF Energy and GitHub, you'll find that there really are only two folders in this particular Git, and one of them is the landscape, and the other one is the governance folder. And in the governance folder, it shows you everything you need to know about the governance of how LF Energy works. And, folks have said, sometimes they say, well, why don't we just, pay for development and then just do a permissive license and put it on a GitHub? You can, but one of the reasons why you want to put it into LF Energy really is to be able to have, the power of the Linux Foundation behind you in terms of being able to bring about the adoption and diffusion of that software so that it can go out and really become the de facto standard. A whole part of what I do is to make sure that the standards bodies are informed, know what's going on, there's working understanding, with the code, and that's just a natural part of the process of how projects evolve. So I'm going to turn this over to Arhan and Benoit, who have not rehearsed. So they barely know this is coming. So this is what I'm thinking. I'm not thinking that we're going to drill really deeply into it, but I do think that it's important because folks have asked, well, what is it that you're doing, and what is LF Energy, and where are you going? And I really believe that the best way to talk about where we're going is to really look at it much more from an architectural standpoint that gets at the functions. And in particular, again, we're talking about high, medium, and low voltage. How are power systems going to evolve, and what are the digital parts of that?
Good afternoon, everybody. Come on here. Yeah, come on stage. Yeah. You have the same screen here. That's nap time now. So my name is Benoit Janson. I work for RTE, and I am in the open source program office as an architect. And with colleagues from Alliander, Tenet, and some other company, but mainly Alliander and Tenet, we worked during the summer on this overall architecture. The idea behind was for us to structure the field of what would be the need for the energy in terms of software. And we started with this first statement here, our commitment to the future digital grid. So I will try to read it at once. To achieve our 2050 climate and energy goals, we, as TSOs and DSOs, have joined together to create a common high-level architecture defining a fit for the future grid. What follows is a start. We want your feedback and involvement With this, we proclaim a commitment under LF Energy to find shared strategic dependencies. By utilizing open source, we can accelerate a technology revolution that enables rapid decarbonization by already the same. Digitalizing the global energy grid. We see that cooperation and working together is the only path to individual and collective success. I don't know it by heart yet, but actually that's our real commitment, and that's what we'd like to do. We put in yellow what sounds important to us, and I won't comment all of the statement, but yes, have in mind that it's a clear commitment that our companies have to this goal, to achieve this goal. And because we're in a fast-moving world and we need to accelerate the development, and open source sounds to be the only viable solution. Am I right?
Yeah, perfectly correct.
Okay, so I have the next. Yes. Maybe next one. I just directly. So we had this first map that is an overall map into 5 pieces of it, and I like to comment it from the ground to the top, because actually the ground is the low level. It's close to our substation, and so in each of these big boxes we see pieces of software that we would like to see open source project to share. The big blocks on the left side and the bottom is the acquisition and control. Actually, we're very, very close to the field, and we gather data here, and that will be necessary for all the other processes. We are close to the edge, and so we distinguished 2 kinds of equipment, the one that are critical and the other that are less critical. And at this edge of our system, we have special nodes. So we try to name them aggregation, substation, distributed, and equipped node. And each of these nodes has special features, and that are communicating all together through a communication infrastructure toward a centralized level that can be materialized by central hub and infrastructure. And you need also to have an infrastructure management to that. Would you like to talk about asset management?
Yes. So, is it still? Yeah. As TSO and DSO together, we call it an architecture, but you could also call it a capability map. And what you see is the things that we have in common, and some things not yet in common, or not at all in common. But the majority of the boxes is. So for outage management, which is meant here actually as planned outages, that's what we do at the DSO level as well, and the TSO level as well. But the outage management here can also be explained as an outage and a fault in the grid. Asset investment planning, that's what we do at the asset management departments, both at the TSO and the DSO. What we see is that there will be much more condition-based asset management. So the process is collecting data, making interpretations, connecting it to device information from suppliers, but also from the past, and draw conclusions to it from how we need to invest and how we actually want to build an investment strategy. I think also that's also the case in Alliander. How well can you evaluate your investment strategy? I think most of the TSOs and DSOs would be very difficult. The asset repository, I think if we look also at Alliander, I think the asset base, is in one place, but there's also asset data in another place. So how do you connect it? How do you make one set which is representative of your whole asset base, such that you can build, for example, a digital twin, do real analytics on it on a consistent manner. So it's about standardization. Asset supervision, which will become, maybe now it's not so important, but in the end it will be very important, I think. We're already talking about grids that are locally controlling themselves. Now, self-control of a grid means that you actually need to know the state of the grid in all sense. So it's not about state estimation only, but it's also about the current condition of the grid in a broad perspective, not only of the primary assets. So how well is my switch working, or how many times has it already switched, how reliable is it, but also the IT around it. And you need to know that in order you can put in controls. Analytics, obviously. So because there's data, there's patterns, unseen patterns, and you want to get them out of the data. That's a skill I think we're collectively building. Everybody individually. We mostly have from the same suppliers, the same assets. So how do we collectively, or can we collectively start building algorithms that do the same analysis or same interpretation or find the same sort of data patterns that are useful for even the TSO or the DSO. Fieldwork management, also very important. That changes also dramatically, I think, due to digitization. If we put in more stations that are virtualized, that's one of the projects that RTE is running now, means that everything the field worker sees physically is not enough. So we live now in a very physical world, and the transition brings also a virtual world, which is unseen, and we have to make it visible for the field worker. And we can also only do that with digital tools. So he needs to interface locally with the virtualized station in order to see what's the condition of the station, what kind of maintenance is needed, etc. So that's also a big chunk with a lot of change in it. Actually, all the boxes, like I described, I think if you look at it now and how we think it should be, there's a lot of change in each of the individual capabilities. Not only from the technical perspective, but also from a skill perspective.
Yeah, so now we're going to the system management box. In the heart of this box, you have the system control. Actually, that's the main tool of the operator today. That's the SCADA system. It is directly connected to the central hub to gather the data from the field and also to control the equipment from the control room. So you have the system control, and so we always use now EMS system, so the ability to perform calculation on the data that you gather, so meaning state estimatory and load flow and any other kind of studies, stability studies and so on. This is under the power system calculation, so we need to have frameworks to perform these calculations, to be able to do it online, and also to be able to have this kind of calculation for the future, for the near future, for example, for the next hours, or the next week, or the next year, or the future years. That's why we need the forecasting. So the forecasting enables us to have hypotheses that will be used to perform study, and that will help. That will support the asset investment planning and the asset management, the outage management tool, and also the real-time operation. And that's also based on this tool that we are able to launch market signals, so such as capacity calculation on the borders, on interconnections, or congestion management. So we're able, with this kind of tool, to simulate the network and send these signals to the market platforms.
Interesting as a DSO talking about customer and market, because we're not so much connected yet to the market, but that will come. Metering and compensation. As I look at DSO, we are slowly getting connected to the market. It's now starting indirectly, at least in the Netherlands. So, for example, TenneT has directly controlled power within the DSO grid. So that means it's a control that activates something in our grid, and we have to manage that. So indirectly we already connected then to the market, because TenneT is connected to the energy market. But for the DSOs, we see also come up local markets. So for example, here in Nijmegen, a city close by, and in Zuidplas, other Dutch area, we have built local flex markets. And there are market mechanisms, not directly connected to the European energy market, but there is a market. And since a few months, we are also live with TenneT with GoPax. That's another market for congestion management, also not directly connected to the European energy market. So there's all kind of markets coming up, and that's where we need to interface with. And one way or another, these markets start moving somewhere. I don't know, but it will happen. And for that, we need to be able to send bills, do proper metering, know what has been used, what has been transported, etc. Well, of course, a customer relationship. Now it's sending paperwork mostly, maybe some emails, but that will also disappear, I think, in a blockchain or somewhere. But we all think if you start, if you have more granularity on delivering consumption on a lower level, on device level, the volume and at which you have to do transactions in order to get it financially sound is big. So we can't do it the way we do it now. So we need to change there as well. Customer response, that is how we see the customer behave to certain, for example, market signals or the contract the customer has itself. So if you turn that around to a grid that is going to control itself, then actually the contracts of the clients are actually the input parameters of the grid in order to get it properly controlled. And now it's somewhere an administration in a database, so that will change as well. And well, the market platform gateway, like I mentioned, there's a lot of markets going to evolve, but somewhere we need to communicate, and there will be interaction between the markets as well. So how do we do that? I don't know, but we will know. That's the main idea behind this.
And the last box is the shared one. Actually, that's the component that we think that are necessary for at least two big boxes. So data management, so it's not that we want to have a proper database system for energy, but we need to be able to manage to implement this kind of the databases related to our own use and having the right data models and so on. So data management first. Actually, systems governance is something that when you see the map, you see, and when you understand how the power system is organized, you understand that there are lots of systems, and actually we are managing a system of systems. And if we want to have something that is resilient, and if we want to supervise it and be able to make it work all the time, we need to be equipped with a relevant system to govern that. Then we need, at a shared level, IT management, supervision, common communication media. And the last sub-box is a unified operator UX components and framework. We don't want to design another new framework, but actually we've, for example, in the control room, and that's not only for the system management, but that can be also for asset management or other. We have other roles. We have people that are working H24/7. And we need to have them proper tools that are able to communicate and coordinate among them, and being able also to display all the information that they get from the various systems in a smart way to enable them to have the right decision. So we have a project on that, and that was to cover this one, that we had this box. So the next slide is actually the animation that is linking all the boxes all together. I'm not sure that's important to comment on that. Probably we missed some. So then you have the details. Everything will be available on GitHub or elsewhere on the Linux Foundation site. We won't go in detail, but that's all the items that we thought of when we developed this map, and that we tried to assemble, to cluster into these boxes. Anything you want?
We don't pretend that this is complete. What we know is missing is the supplier side and the generation side.